Hi guys, welcome back to my channel. Today we are going to talk about the number system. That is the different types of numbers we have. First, we are going to talk about the natural numbers. The set of natural numbers is the set that contains all those numbers we can count, and it contains only positive whole numbers. Positive whole numbers. When we say positive whole numbers, we mean numbers starting from 1, 2, 3, 4 down to infinity. The set of integers is the next one we are going to consider. It's a set of all those negative whole numbers from minus infinity down to 0, and all positive whole numbers down to infinity. So that is a set of integers. So the set of integers include all negative and all positive whole numbers, including 0. The next one is a set of complex numbers. The set of complex numbers is divided into two parts. A complex number rather is divided into two parts, the real part and the imaginary part. When we talk about a complex number, we are talking about numbers in the form x plus iy, where x is the real part and y is the imaginary part. Example, suppose we want to take the square root of a negative number minus 4. Please take note that we often talk about a complex number as a result of trying to take the square root of a negative number, because the square root of a negative number often leads us to something imaginary, thus leading us to a complex number. So suppose we want to take the square root of minus 4. Is the same thing as square root of plus 4 times square root of minus 1. Square root of plus 4 we know to be plus or minus 2. But then square root of minus 1 is what? Now in high school level, when we're solving some equations, let's say a quadratic equation, and we happen to have the square root of a negative number, we often stop there. We say the answer is imaginary. Now there's a way of simplifying it further. In advanced levels, we notice that we can simplify the square root of a negative number, having in mind that the square root of minus 1 is what we call in complex number system I. So the square root of 4 is plus or minus 2. The square root of minus 1 is I. So we can say the square root of minus 4 is plus or minus 2i. Now this 2i happens to be just the imaginary part. So if we want to represent this number a equals square root of minus 4 in the complex number system, we say a is equal to 0 plus or minus 2i. 2i is the imaginary part we just got. Now this number has no real part. That's why we assign a value to it, 0, to show that there's 0 real part. So this is how the set of complex numbers look like. The next type of number we are going to talk about is irrational numbers. A rational number is a number that can be expressed in the form a over b. In other words, a rational number is a number that can be expressed as a fraction, where the numerator a and the denominator b all are integers. They are in the set of negative and positive whole numbers. But the denominator b must not be 0. What happens if the denominator is 0? We know that in mathematics, anything over 0 is undefined. So if b is 0, the whole of this fraction becomes undefined. So b must not be equal to 0. Now, this rational number in their decimal part, they either terminate at a point or recur in a particular pattern. For example, we have 1 over 2. This is in the form a over b. Now, in its decimal part, it can be written as 0.5, terminating at a point. Other rational numbers can be written as 1.25, terminating at a point. Sometimes it can be longer, but it will surely terminate at a point. But if it does not terminate at a point, it will recur in a particular pattern. For example, this 1.3333333333. We often make divisions and notice the answer appearing in this way. 333 continues in that pattern. Or something like 0.49595959, 2.818181, something like that. So the bullet point here is A rational number can be written in the form numerator over denominator, but the denominator must not be equal to 0, otherwise the fraction would be undefined. In its decimal form, it either terminates at a point or recurs in a particular pattern. How about an irrational number, which takes us to point 5? Irrational numbers is a set that is exactly opposite the set of rational numbers. It is a set that cannot be expressed as a fraction. It cannot be expressed as a fraction, and it neither terminates at a point nor recur. You can look at this number, 1.3465297. It continues. It does not have a pattern of recurrence. It does not terminate. Another example is the square root of 5, square root of 2. Now, square root of 5, if you check the value, you're going to notice that it does not have a recurring loop and it does not terminate at a point. Put simply, the square root of a number that is not a perfect square is irrational. What do I call a perfect square? What I call a perfect square is like 4. The square root of 4 is 2. For example, let's check it out here. Square root of 4. Square root of 4 is equal to 2. So 4 is a perfect square. The square root of 16 is equal to 4. So 16 is a perfect square. The square root of 25 is equal to 5. 25 is a perfect square, and so on. But how about the square root of 7? If you check the square root of 7, you are going to notice the answer appearing in decimal form. That makes this 7 not to be a perfect square. So the square root of such numbers that is not a perfect square is a rational number. 5 is not a perfect square, its square root is rational. 2 is not a perfect square, its square root is irrational, etc. Now I'm going to ask a question about this pi at the end of the class. Let's just proceed for now. The sixth type of number we are going to consider is the whole numbers. The set of whole numbers is a set of counting numbers including 0. Now earlier I talked about the set of natural numbers. All those counting numbers from 1 to infinity, excluding 0. The set of whole numbers includes all those counting numbers, including 0. So the difference between the set of natural numbers and the set of whole numbers is the set of whole numbers includes 0, starts from 0 to infinity, while the set of natural numbers starts from 1 to infinity. So we can summarize everything using this chart. This is a real number system. We can see that the set of natural numbers is a subset of whole numbers because the set of natural numbers has no 0, but the set of whole numbers includes 0. Both of them in turn are subsets of integers because they all have what the set of integers have. 3 of these sets, whole numbers, natural numbers, integers, are all subsets of the real numbers. All subsets of the real numbers. So we can see that irrational numbers is very different from this. The set of irrational numbers is different from this. Is the subset of the real number system, but is not part of this, the rational numbers. The set of integers, natural numbers, and whole numbers are all rational numbers, and in turn are all subsets of real numbers. But the set of irrational number is just the subset of real numbers. It's a different set entirely, but both rational and irrational make up the real number system. Rational and irrational make up the real number system. So, in summary, the set of integers, negative and positive whole numbers including 0. The set of natural numbers, only positive whole numbers from 1 to infinity. The set of rational numbers, numbers that can be written as fractions or terminating decimals or recurring decimals. The set of irrational numbers cannot be written as fraction and neither terminate nor recur. The set of complex numbers can be written in the form x plus iy, that is, have both real and imaginary parts. I said I'd come back to asking a question here. Now, we often say that pi is equal to 22 over 7. When we're solving problems, you often say pi is equal to 22 over 7. If pi is equal to 22 over 7, it means it is written, or it can be expressed in the form a over b, numerator over denominator, which should make it fall under rational numbers. But why do we then say that pi is an irrational number? Yeah, if you want to know why pi is an irrational number, though it can be expressed as a rational number, 22 over 7, hit the subscribe button and follow my next video to understand it. Bye for now.